You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone, and fellow fire ecologists. We got a really fun show for you today. We're going to be talking about the paper that was recently published in the journal called Forest Cover Buffers Microclimate and Increases Fuel Moisture in Northern Conifer Forests, a terrestrial laser scanning approach. This paper was published in the journal Fire Ecology. Fire Ecology is a journal that is published by Springer, but it is overseen by the Association for Fire Ecology. And I was their editor. Our new editor is now Jeff Keane. But that doesn't matter now because we're going to be talking about a wicked cool paper. And I've got Jay and I've got Peter here to talk about the paper. Peter, why don't you go ahead and introduce yourself?
Hey, Bob. Thanks for having us. I'm Peter Breigenzer, and this study was part of my graduate research at the University of Maine. And I now work for the U.S. Forest Service in Montana doing fire and fuels management.
Wonderful. Welcome aboard, Peter. And Jay?
Hi, Bob. Yeah, I'm Jay Wason. I'm an associate professor in the School of Forest Resources at the University of Maine up in Orono, and I was advising Peter during his master's degree here at the University of Maine.
Well, I really appreciate you guys coming on the show and talking about your recently published paper, which I found was really exciting. Peter, why don't you give us a little thumbnail sketch of the paper?
Yeah, sure. While forest vegetation is often viewed as just fuel for fire, it also interacts with local weather to create unique microclimate conditions in the understory. So our study used multiple measurements, including terrestrial lidar, or TLS, to better understand how forest cover affects understory temperature, understory relative humidity, and dead fuel moisture in mesic forests of the Northeast U.S., which has major implications for fire management in that region.
I was really excited to read this paper. Exactly why did you do it?
Yeah, so the idea for this project first started when I was working on some prescribed burns in Maine and New Hampshire. And while we had no problem achieving our burn objectives in open areas, we often couldn't get fire to carry in the forest understory. So at that time, I was a grad student at the University of Maine studying forest microclimates, and I saw an opportunity to expand my master's research in order to support fire management and research in the Northeast US. And so we assembled an incredible team of experts in forest and fire management from around the region, and we started the project.
For our listeners, kind of took a pause when you said prescribed burning in Maine and New Hampshire, because that just doesn't make a lot of sense to them. But by God, you're right. There is a lot of prescribed burning that goes on in those two states. And one thing that's really important is that prescribed burning takes special methods in order to understand how the prescribed burn affects the environment. So, Jay, you want to talk about the methods that we use in the study?
Yeah, sure. And we certainly did rely on a lot of those other experts that have experience in this realm. The fun thing about this project for me was that I had never done a project related to fire before Peter expressed the interest as a student of mine. But I did have a lot of experience working in forests and working with microclimates. And so the basic methods for this project were that we went out to two different locations, one in New Hampshire and one in Maine, and we put out a bunch of sensors in those forests, in both closed canopy forests and open forest areas, that we could measure the changes in the environmental conditions and how that relates to the canopy above them. And then the important additional piece we added was putting out fuel moisture sticks in those forests so that we could track over time how the fuel moisture is related to those environmental conditions that they're experiencing. And that allowed us to draw those empirical links between all of those different variables. And the cool additional piece that got added here was the terrestrial laser scanning approach. And so Peter was also able to do these digital scans of the forest with this cool device that essentially shoots lasers all over the forest, right, to measure the structure of the forest around you, and then try to link that up to see if that can help us better understand the fuel moisture dynamics as well in these stands.
Yeah, live and dead fuel moisture is the elusive thing that we always try to look at in fire, and it's hard to get. So, Peter, how about a little peek under the sheets at the results and give us an idea of what you found?
Yeah, we found that forest structure strongly affects understory microclimate and dead fuel moisture, especially in mesic forests of the Northeast US. Specifically, we found that open areas had daily maximum temperatures that were nearly 8 degrees Celsius warmer and had daily minimum relative humidities that were nearly 25% lower compared to closed canopy plots. And in addition, we found that open areas had 10-hour fuels that were nearly 8% drier than closed canopy plots. We also found that terrestrial laser scanning provided better predictions of dead fuel moisture when compared to traditional forest inventory metrics. We attribute that to LiDAR's ability to capture structural variation that is otherwise difficult to measure with traditional methods.
Yeah, that is incredibly interesting. So what do these amazing results mean to managers and other scientists, especially when you talk about prescribed burning in two of the most inhospitable places in the United States?
That's right. So while fire management and research in the Northeast US might not receive the same level of attention as that in the Western US, these are still vitally important fields in this region for maintaining forest health and resilience through prescribed fire, as well as improving fire suppression efforts where necessary. So this study is particularly relevant to fire managers who work in these mesic forests, because in areas with naturally higher humidity, the effects of forest cover on understory conditions are magnified compared to arid forests of the Western US. So while fire managers in Western forests often thin to reduce fuel and promote lower intensity fire behavior, managers in the east often need to thin in order to get fire to burn in the understory to increase fuel availability. So our study provides insight into these management activities by showing how forest cover affects understory microclimate and dead fuel moisture. And another exciting thing from our study is that our results really show that terrestrial laser scanning can be super helpful for fire and fuels monitoring due to how quick and easy it is to scan plots and how effective the data was at predicting understory microclimate and dead fuel moisture.
Well, it certainly is an interesting paper. And for those of you who love fuels and like to know about fuel dynamics, boy, I would suggest this as a big read. I want to thank you both for coming on and giving us a talk. Jay, would you like to recognize any co-authors or funding agencies?
Yeah, of course, this project wouldn't have happened with all the co-authors that helped us understand the results, plan the study, and everything related to the management implications. So Sean Fraber here at the University of Maine was instrumental. We had 3 folks from the U.S. Forest Service Northern Research Station, Michael Gallagher, Laura Kenefek, and Aaron Lane. And then John Neely from the New Hampshire Department of Natural and Cultural Resources really helped with the on-the-ground stuff that we were doing in New Hampshire, which was essential. I also want to call out our funders real quick. And so Peter was awarded the Joint Fire Science Program's Graduate Research Award, which helped fund this research, and it was also supported by the Maine Agricultural and Forest Experiment Station here at the University of Maine.
Yeah, Joint Fire Science, man, that was a great, very productive research venue. I'll tell you what, wonderful papers have been published out of there. Now, listeners, if you found this paper or this podcast to be incredibly interesting, you can download it for free. That's right. Peter and Jay have already paid the freight for you to go ahead and download that paper, and you can do it at no cost whatsoever. And you can read all about this really interesting study. Please tune in again to our next Fire Ecology Chats.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. FIREECOLOGY.org.